Hi Year 6 and thank you for joining me for another maths lesson. So we have been doing area and perimeter, and today we're going to use both of these concepts to kind of problem solve a little bit. Okay, so I'm going to share my screen and hopefully you can now see me and you can see the PowerPoint. So today then, we are going to be working out the area and perimeter of 2D shapes, but it's going to be a bit more of a problem solving lesson. So I might give you the area or I might give you the perimeter and you've got to work out the dimensions of the shapes. So make sure that you are looking for clues in the questions, like, is it a square? If it's a square, all the sides are the same length. Is it a rectangle? If it's a rectangle, then you know you've got two top ones would be the same length and the two side ones would be the same length. Okay, is there a clue in the question where actually they've already told you the area and you need to work it out? So rewind then to start us off. What is area? What is perimeter? You should have these STEM sentences written down. If you haven't, write them down now into your jotters. Okay, off we go. So what is area then? So area is the space inside a 2D shape. What is perimeter? Perimeter is the length of the outside of a 2D shape. So perimeter is when you would like walk around the edge of something, and the area is that bit in the middle. Okay, so here on my screen then I have a rectangle for you, and I would like you to work out the perimeter and the area. Make sure you get them the right way around. Pause the video and off you go. Okay, hopefully you've managed to do that then. So I'm going to put A for area, and to work out area, we need the length and the width. So I've got 12 and 8, and we do which operation? We times, okay? Because that's then the length times the width, and that gives us all that space in the middle. So 12 times 8 is 96. 96 what? Centimetres squared. I'll see if I can do the little squared side. Okay. 96 centimetres squared. Why is it squared? Well, because it's centimetres times centimetres, which will be centimetres squared. It's 2 dimensions, so it's centimetres squared. And if we filled this rectangle up with squares to make it 12 across and 8 down, there would be 96 squares in total. Okay then, so we've got the area. Now let's work out, oh, that one's got more tiny. Now let's work out the perimeter. So the perimeter is the length around the outside of the shape. Few ways you can do this. We can either do 12, add 8, add 12, add 8. Could work it out like that. You could, this is slightly more efficient, we looked at this yesterday, you could do 12 times 2, because there is 2 lengths that are 12 centimetres, plus 8 times 2, okay, because there are 2 lengths that are 8 centimetres, 2 lengths that are 12 centimetres. Doesn't matter which way around you do it, you would get the same answer. Okay, so I'm going to do it the more efficient way because I think it's easier. So 12 times 2 is 24, and we're adding it to 8 times 2, which is 16. Add those together, so 20 add 10 is 30, 6 add 4 is 10, add them together, 40 centimetres, and just centimetres because it was just one dimension, it was just the length all the way around the outside this time, so just centimetres. Right, lovely, well done if you got that right. Okay then, here is our discover for today. So, like I said, it's a problem solving one. You've really got to read this and you've really got to think about the key information. Okay, we've got Lee and we've got Jamila. So, I'm looking at the problem, I'm looking at the pictures, any kind of clue like that is fantastic. So the context of this problem then is we're at the school fair and they're selling handmade birthday cards. So, Lee is saying, we use ribbon to decorate the edges of the card, the outside of the card. Already start to think, what mathematical thing do we know about this? Something's on the outside. And he says that they used 32 centimetres of ribbon for each card. Hopefully you can tell me something about these cards already then. What can you tell me? Well, hopefully you can tell me that if they're using ribbon to decorate the outside edges of the card, that's the same as the perimeter of the card. And he's told us that the length of ribbon that they used was 32 centimetres. So I know that for every single card, the perimeter, the outside of it, is 32 centimetres. You're going to need that bit of information. Jamila then is saying that Lee's card is a square, her card is a rectangle. And she's telling you that the length of her card is 10 centimetres. So she's saying that one side of her card is 10 centimetres. Okay. Bear in mind what we've already written down on the board and what Lee has told you. Now you need to use what Jamila has told you to work out the area of Lee's card and the area of Jamila's card. You can work this out. Remember what we said about squares. Pause video and have a go. Okay, so hopefully you've had a good go at that. Ooh, so the perimeter was 32 centimetres, and we got that information from Lee over here. So we're now going to explain how we work this out. I'll try and get my annotation up. There it is. So now I can annotate the top of it. Okay. Oh, no. Jamila said that Lee's card was a square. What do we know about squares? We know that they have four sides the same length. So here is Lee's square, there's his card. And we know that the perimeter has to add up to 32. So whatever the length of the side is, whatever it is, you times it by 4 and you get 32. So I did 32 divided by 4, so 32 centimetres of ribbon shared between 4 sides of the card. So 32 divided by 4, each side would be 8 centimetres. Okay then, so if we know that, area B, what would the area be? Well, you would do 8 times 8, because that is each side is 8 centimetres, and we times the length and the width. 8 times 8, and 8 times 8 is 64. 64 what? Centimetres squared. And I just need to do the little subscript. Make sure. There we go. 64 centimetres squared. Perfect. Right, I'm going to keep seeing things appear, it's because I'm just copying and pasting everything over, so I have got it all there for me. Right, let's have a look at Jamila's card then. So information then, Jamila told us that her card was rectangular. So here is the rectangular shape. Did you tell us something else? Help us. Did you tell us something else? Well, Jamila also told us that the length of one side of her card was 10 centimetres. So it doesn't matter which way around you labelled it. You could have had your 10 centimetres up here. You could have had your 10 centimetres down here. It didn't matter. But one of the lengths has to be 10 centimetres. She also told you her card was a rectangle. So if her card is a rectangle, that means that 2 sides are the same and the other 2 sides are the same. So if this side was 10 centimetres, this side also needed to be 10 centimetres. Hopefully it's starting to make a bit of sense now. So I know that this side is 10 and I know that this side is 10. So far the perimeter would be 20, but I needed it to be 32. So what's that missing part then? The whole perimeter is 32. Part of it is 20. What's the missing part? Well, the missing part, 32 take away 20, will be 12 centimetres. Is one length 12 centimetres then? Well, no, because I need it to have 2 sides, otherwise I've made a triangle. So I need to do 12 centimetres divided by 2. So each side is 6. Right, let's check I've got that right then. Well, 6 add 6 is 12, 10 add 10 is 20, add them together, 32 centimetres. Okay, I hope that makes sense how I got there. Now then, we know what the card looks like. We now need to work out the area. So to work out the area, we need the length, we need the width, and we multiply. We times them together. So then the area would be 6 times 10, which would be 60 centimetres squared. Okay, I told you we needed our problem solving hats on today. Okay, it might look tricky, but the more we go through it, the more it will make sense. Okay, and you'll start to spot the tricks as we go through. Okay, then here is our think together. We've got 3 different gardens, A, B, and C, and each garden has a perimeter of 20 metres. So straight away, I'm going to write down P equals 20, and not centimetres this time, metres. Okay, I need this piece of information. I also need the information that each of the gardens has a different perimeter. Sorry, these 3 gardens are different, okay? That might help me as well. Any information I'm going to keep in my brain so I don't forget it. The perimeter equals 20 meters. So here we are down here at A, and A is very helpfully labeled part of it for us. So this side here is 1 meter. What else could I label straight away? If I know that this length is 1 meter, yeah, meters, not centimeters. I know that this length is also 1 meter. So I know both of those. And now I need to work out these missing lengths here. So if I thought about this, you might want to use a bar diagram to help you work this out as well. The whole garden has got a perimeter of 20 meters. I know 2 little parts of it. Okay, I know one part is 1 meter, and I know another part is 1 meter. Sorry, this isn't the most accurate of diagrams. And I now need to work out the missing part. I now need to work out this line and this line. And what do I know about them? I know that they are the same. So I know that I have got 2 equal parts left over. Okay, so if I'm then labeling this, I know that this is 1 meter, and I know that this is 1 meter, and this, add this, add this, and these need to equal 20. So if I think the whole thing is 20, I take away these 2 meters here, I take away what I already know, I know then that these 2 lengths, these 2 parts need to equal 18 meters. So this length and this length equals 18. Okay, how can I work out then what one length would be? Well, I know that these lengths are equal. I know that they are the same. So I need to do 18 divided by 2. So I know that each length is worth 9. So this is 9 meters and this is 9 meters. Right, let's check it then. So if I've done this correctly, the perimeter should add up to 20. Well, 9 add 1 is 10, 9 add 1 is 10, add it together, 20 meters. Perfect. What's the area then of A? Well, the area would be 1 times 9, which would be 9 centimeters squared. Well done if you got that correct. Just going to get rid of all my drawings. There we go. Okay. Next one then. Let's have a look at B. Right. Ooh. Sorry, not quite sure what I did there. So with B, what information do we have about B that might be able to help us? Well, B has got these strange lines on it. What do these 4 lines mean here? Well, those 4 lines mean that this length is equal to this length, which is equal to this length and equal to this length. So any lines that have any lengths have got these lines on them, it means that they're the same. So this tells me that all 4 sides are the same, which tells me that this is a square. So this time then, I've got my bar model, the whole is 20, and this time I'll try and draw it as accurately as I can. This time I've got 4 equal parts because each one of the lengths is the same because it is a square. My original bar model a little bit smaller. So while I'm doing this, have a think about if you know the whole thing equals 20 and you need to split that into 4 equal parts, what would each length be? Well, 20 split into 4 divided by 4, 20 divided by 4 would be 5. So you know that each length would be 5 meters because 5 add 5 add 5, 5 add 5 add 5 add 5 would be 20. So the perimeter would be 20 still, and each one of these would be 5 meters. Right, area then. So for area, we find the length, we find the width, and we times. So 5 times 5 is 25. 25 meters squared. Brilliant, well done. I think hopefully it's starting to make a bit more sense now. Let's try the next one then. So for C, tell me, what information do we already know? Well, we already know that one length is 4 meters. What else can I label straight away then? If I already know that one bit is 4 meters, what else can I label? Well, hopefully you are telling me that if you know that this side's 4 meters, you know that this length is also 4 meters. So my bar model then, this part equals 4 and this part equals 4. I now need to have 2 more equal parts here. So I'm going to draw it and then cut it in half. That then all together, ooh, hello, not sure how I managed that. Add up together to make 20. Sorry, this isn't the most accurate, but hopefully you understand where I'm going with it. So I know that 2 of the lengths together have a perimeter of 8 meters. So what must this part here then be? What must these 2 lengths equal? If these 2 lengths equals 8 meters, what must the other 2 lengths equal to make sure the whole thing is 20? Well, 8 add what is 20? 8 add 12 is 20. So that tells me that these 2 parts, 2 equal parts make 12. So if the 2 equal parts make 12, one part must be 6. So this must have a length of 6 here and a length of 6 here. What's the area then? Well, 6 times 4 is 24, so it'd be 24 meters squared. Brilliant, well done. Let's move on to the next one. Right, okay then. So we're now going to move on to our independent activity. So I'm only going to give you 2 questions, 2 questions today, okay? Because this is tricky. We're doing really well with it. It's all about the problem solving. It's about thinking about everything we know, but we're only going to have 2 questions today, okay? So you're nearly there. Keep going. So 1A, can you calculate the perimeter and area of each shape? Okay, so you can pause the video. You can have a go. Remember, if the squares are there for a compound shape, which is 2 shapes stuck together, just like a compound word is 2 words together, compound sentence is 2 sentences, simple sentences joined together. So a compound shape is 2 shapes joined together, or more than 2, sorry, like this one here is like 2 rectangles stuck together. Remember, if the squares are there, you can just count squares, okay? Once you've done those, have a go at that one, then what do you notice about the shapes? Okay, so what's the perimeter, what's the area, what do you notice? So that's question 1. Pause the video, have a go. Okay, when you've done that one, here is question 2. So fill in the missing numbers. What do you notice about the numbers? So remember, they've given you the perimeter. Pause the video, have a go. Okay then, hopefully you've given that a go. Let's work these out together then. So first of all, we will do the perimeter of A. So this should have been hopefully quite nice and easy for us to do. So A is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 centimeters. Area 1, 2, 3, 4, 5, 6, 7, 8 centimeters squared. This is almost a bit of a rewind back to yesterday's lesson as well. So hopefully this wasn't too tricky. B, perimeter, go round the outside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 centimeters as well. What would the area be? Well, let's count the squares. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 what? Centimeters squared. Ooh. Maybe by the end of this, I'll be better at writing on a computer screen. And remember, you could have turned this into 2 rectangles. So the area of this one would be 2 centimeters squared. The area of this one would be 3 times 1, 2, 3, 3 times 4, which would be 12. And then you would add them together to get 14 centimeters squared. You can do it either way. C then is a square. So I know it's 1, 2, 3, 4 centimeters across. So 4 times 4. Or 4 add 4 add 4 add 4, repeated addition, 16 centimeters. Let's do the area then. Well, the area is going to be 4 times 4, which is also 16 centimeters. So this one is 16 centimeters squared. Last one then for D, perimeter would be 1. And then the bottom you could also do 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So also 16 centimetres, and the area then would be one, oh, I've just counted it as well, 1, 2, 3, 4, 5, 6, 7, there we go. Would help if I labelled this better, but it's really difficult on the computer screen. So 7 centimetres times 1 centimetre would be 7 centimetres squared. So the B part of this question was what do we notice? Well, hopefully you can notice that the perimeters of all of these 4 shapes was the same, but the areas were completely different. Okay, and this is kind of the whole idea of perimeter and area, is that a shape like C can have the same perimeter and the same area, but they also can have very different perimeters and areas. And just because a shape's got the same perimeter, it doesn't mean the area is the same as well. Okay, so let's clear that off and go down to 2. Right, find the missing numbers. So for this one, you needed to remember this information. Bottom, you needed to remember that the perimeter was 18 centimetres. So if you know that this length is 7, which other length can you label straight away? Hopefully you can also label this one, which is also 7. Well, 7 add 7 is 14. The whole is 18. You've got 14, so what have you got left over? You've got 4 left over, and you need to split that 4, divide that 4 into 2 lengths, because you've got a length here and a length here. So 4 divided by 2 is 2. So each width then is 2 centimetres. Let's check it. Well, 7 add 7 is 14, 2 add 2 is 4, 14 and 4, 18. Perfect. What's my area then? Well, my area, I would do 7 times 2, which is 14 centimetres squared. Well done if you got that right. Next one then, key fact, perimeter is 18 centimetres again. This time then, we know that we've got 3 centimetres here. So if this length is 3 centimetres, what else can I label? Well, I can label this length, which would also be 3 centimetres. So that's 3 add 3 would make 6, and my total is 18. So what's the part that's left over? The total is 18, this part is 6. So the other part then must be 12, 18 take away 6 is 12. I then need to split that 12 into 2 equal parts, because you've got this length and this length. So then I've got 12 divided by 2, which would be 6. So each length would be 6 centimetres. So let's check that I've got that right then. Well, 6 add 6 is 12, 3 add 3 is 6, add them together, 18. So my perimeter is correct. Area then, I'm going to do the length times the width, 6 times 3, which is also 18 centimetres squared. Right, really, really well done. That was quite tricky, bit of problem solving. Hopefully that all made sense, and hopefully you've given it a really good go. So send a picture of the working out that you've done in your maths book or your maths jotter, add it to your portfolio, and then I can see how we've been getting on. Right, well done. See you later.